So when we add a solute into solution or into water to make a solution, what happens to make that solute dissolve? Well, what happens is our solute particles have attractions between themselves. So they are held together by attractive forces. When we put them into the solvent, which also has attractive forces between the molecules, they have to overcome the attractive forces between the solute and the attractive forces between the solvent in order to mix or dissolve. So if the attractions between the solute and the solvent are strong enough, it will dissolve into solution. If the attractions are too weak, it'll stay as a solid. So for an example like sodium chloride, the positive sodium is attracted to the slightly negative part of water. So water has a slightly negative part on the oxygen, has a slightly positive part on the hydrogen, and the positive part is attracted to the chloride, the negative part is attracted to the sodium. And that pulls the sodium and the chloride apart, and the ions get surrounded by water molecules. So materials that dissolve in water, and they do have to dissolve in order to become electrolytes. When they dissolve in water, if they have ions that can carry electricity, they are called electrolytes. So this is formed from ionic compounds because they have to have those positive and negative charges to carry the electricity through the solution to light up the light bulb in this case, but to conduct electricity. If they cannot carry charge, or they don't have charge, they can't carry the charge through the solution, and they will not conduct electricity. And these are going to be molecular compounds, or covalently bonded compounds, nonmetals bonded to nonmetals. It is also possible to have ionic compounds that do not dissolve, and then because they do not dissolve, they will not carry that electrical charge. So if we look at this on the molecular level, you'll see that our ionic compounds, such as sodium chloride, get surrounded by the water when they dissociate into ions, and they dissolve. Our molecular compounds, they do not dissociate, they stay as the molecule, but they still get surrounded by the water in the solution. But they stay as the entire compound, and which means they're not available to conduct the electricity. Acids are a special type because acids are actually molecular compounds. They're made out of all nonmetals, but they do ionize when they dissolve in water. They form ions. And our ions are H plus for the cation from the acid, and then whatever anion it's attached to. And the amount of the molecules of acid that ionize, it varies from one acid to another. So if nearly 100% of them dissociate or ionize, then we call them strong acids. So it has nothing to do with the concentration, it just has to do with how much those molecules fall apart in the water. So if we form nearly 100%, if we have nearly 100% ionization, it's a strong acid. An example of that would be hydrochloric acid, so HCl. Falls apart, dissociates nearly 100% in water. There are also acids that only ionize a small percentage, so most of it stays as the molecule, and only a small percent forms into the ions. And so an example of that is hydrofluoric acid. Most of it stays as HF, and only a small part of it becomes H plus and F minus. And you'll see a double-headed arrow or an arrow with points going both directions, showing that it goes both in the forward direction and the backward direction if it is a weak acid. So strong electrolytes follow the same definition. Strong electrolytes are materials that dissolve completely as ions, and it includes strong acids, and their solutions conduct electricity very well. Weak electrolytes, they dissolve only in a small amount to produce ions. This includes weak acids, and they do conduct electricity, but not nearly as well. So if our compounds contain polyatomic ions, when they dissolve, the polyatomic ions stay together because they have covalent bonds that hold them together. They do have charge, but those covalent bonds stay together. And so, for example, our acetic acid, our acetate remains intact with the charge when it dissociates, when it ionizes in the water. So this acetic acid, you may more commonly know it as vinegar. So dilute solutions of acetic acid are vinegar. So pause the video and see if you can write the dissociation reaction. So what ions do you get when you put these compounds into water? Our calcium chloride is going to form a calcium with a +2 charge. And we usually, when we're writing dissociation reactions, write AQ. And we get 2 chloride ions. Please note that it is not like this. You do not write Cl2. That 2 becomes a coefficient showing that there's 2 chloride ions. Our nitric acid, we're going to get H plus as our cation, and the nitrate as the anion. And again, the polyatomic ion stays as a complete unit. Ammonium carbonate, we get 2 ammoniums. And 1 carbonate when it dissolves in water.